Here we have a problem on arithmetic series. Okay, let's go to the question. Find the sum of all 3-digit natural numbers which are divisible by 7. Okay, here to get the sum of all 3-digit natural numbers which are divisible by 7, first let me write all 3-digit natural numbers. So here we have 100 is the first 3-digit natural number. So then we have 101, then we get 102, 103, and it keeps going. And the last 3-digit natural number is 999. Okay, here I have to identify the 3-digit natural numbers over here which are divisible by 7. For that, what I am going to do is I am going to divide the first 3-digit natural number, that is 100 by 7. Let me do it. So here, when I try to divide the first digit 1 by 7, but 7 goes into 1 0 times. Now let me take the number formed by the first 2 digits, that is 10. How many times 7 goes into 10? 1 times. 1 times 7 is 7. When I subtract 7 from this 10, I am getting 3. How many times 7 goes into 3? 0 times. So we have to bring this next digit down. When I bring this next digit 0 down, I am getting 30 over here. How many times 7 goes into 30? 4 times. It is 4 times 7 is 28. So when I subtract 28 from 30, I am getting 2. So when I divide the first 3-digit natural number 100 by 7, I am getting the remainder 2. So the first 3-digit natural number 100 is not divisible by 7. So what is the first 3-digit natural number which is divisible by 7? What do we have to do for that? So do we have to check 1 by 1, 101, 102, 103 until we get the 3-digit number, natural number which is evenly divisible by 7? Actually, it will take a long time to check 1 by 1. So there is an idea to get the first 3-digit natural number which is evenly divisible by 7. So for that, let's continue the stuff we have done over here. So here we got the remainder 2. Now you have to subtract the remainder 2 from the divisor 7. When I subtract 2 from this 7, that is 7 minus 2, I am getting 5. That 5 should be added to this dividend. So when I add 5 to this dividend 100, I am getting 105. So 105 is the first 3-digit natural number which is evenly divisible by 7. So if you want, you can check it out. Like you can divide 105 by 7. Let me do it. 7 goes into 10 one times. 1 times 7 is 7. So when I subtract 7 from 10, I am getting the remainder 3. Let's bring this digit of 5 down. Then I am getting 35. 7 goes into 35. 5 times 7 is 35. So 35 minus 35, we get 0. The remainder is 0. That is 105 is evenly divisible by 7. That is 105 is the first 3-digit natural number which is divisible by 7. So this is how we have to get the first 3-digit natural number. Okay, now to get the next 3-digit natural number which is evenly divisible by 7, what we have to do is we have to add 7 to this. Okay, when I add 7 to this 105, I am getting 112. To get the next number which is divisible by 7, we have to add 7 to this one. I am getting 119. To get the next one, again I have to add 7 to this one, then I'm getting 126. In this way, I can keep on adding. Okay, what is the last 3-digit natural number which is evenly divisible by 7? For that, I have to consider the last one, 999. Now I have to divide this 999 by 7. 7 goes into 9 1 times. So 1 times 7 is 7. When I subtract 7 from 9, I'm getting 2. 7 goes into 2 0 times. So we can bring the next digit down. Then we get 29. 7 goes into 29 4 times. That is 4 times 7 is 28. When I subtract them, I am getting 1. We can bring this next digit 9 down. 19. 7 goes into 9. 2 times 7 is 14. When I subtract 14 from 19, I am getting 5. Okay, the last 3-digit natural number 999 is not divisible by 7 because when I try to divide this one by 7, I am getting the remainder 5. Okay, so how do we have to get the last 3-digit natural number which is evenly divisible by 7? For that, we have to subtract the remainder 5 directly from the dividend 999. When I subtract this 5 from this 999, I am getting 994. So this is the last 3-digit number which is evenly divisible by 7. Okay, now to get the first 3-digit number which is evenly divisible by 7 and to get the last number which is evenly divisible by 7 are different. The process are different. So here we subtract this remainder from the divisor, then add the result to the dividend to get the first one. But here to get the last one, directly we subtract the remainder from the dividend. So to get the last one. So these are all the 3-digit natural numbers evenly divisible by 7. According to the question, we have to add all these numbers and get the result. That is, I have to add these numbers over here. So what type of series do we have over here? So it's an arithmetic series with a common difference of positive 7. Because when I add 7 to this one, I'm getting 112. When I add 7 to this one, I'm getting 119. So this is an arithmetic series with a common difference of positive 7. Okay, let me write the stuff. A1 represents the first term of the series. Here it's 105. That is A1 equals to 105. and D is a common difference. Common difference means the difference between any two consecutive terms along the series. Usually to get the value of D, we will subtract the first term from the second term. When I subtract 105 from the second term 1 and 12, I am getting 7. And AN represents the last term or nth term, that is 994. Okay, let me write it. And there is a formula to find the sum of the terms in an arithmetic series. So that is Sn equals to n divided by 2 times a1 positive an. Okay, now what we need is we need the value of n. N represents the number of terms in this arithmetic series. And so here we know that an is equal to 994. Let me write it. An equals to 994. Actually, an represents the nth term. There is a formula for nth term of an arithmetic series. That is a1 positive d times n negative 1. This is the formula for nth term, that is an equals to 994. Now we can plug in the value for a1, that is the first term 105, and the d is 7. 7 times n negative 1 equals to 994. Okay, 105. Now we can distribute this positive 7 to this n and negative 1. Then I'm getting positive 7n. Negative 7 equals to 994. Okay, now 7n. When I combine this positive 105 and negative 7, I'm getting positive 98 equals to 994. So now what I can do is I can subtract 98 from both sides. When I do so, I'm getting 7n is equal to 896. Now to get the value of n, I have to divide both sides by 7. When I divide both sides by 7, I'm getting n is equal to 128. That is, there are 128 terms in this arithmetic series. So that is, there are 128 three-digit natural numbers which are divisible by 7. Okay, now in my next step, what I have to do is I have to plug in this 128 for n over here. Here, let me do it. Then we get S128. That is sum of all the 128 terms in this arithmetic series. So here 128 divided by 2. And here A1 is the first term, which is 105. And an is the last term. An means that is a 128th term, that is 994. Okay, so here when I divide this 128 by 2, I am getting 64. When I add this 105 and this 994, I am getting 1099. Further, when I multiply the 64 and 1099, I am getting 70,336. That is, the sum of all three-digit natural numbers which are evenly divisible by 7 is 70,336.